All right, welcome to section 8.1 in the Rolf book, frequency distributions. So basically this is how numbers are distributed. This example is the PBIS cards that are done at the school, and 180 were marked respect, 195 were marked communication listening, 64 were marked safety, 248 were marked solving problems, and 20 were like randomly put in there. Some people even made up their own markings for some reason. So the first thing we need to know is how many cards were collected and counted. So I added the numbers together and got 707. So the total here is 707. So that total is called the frequency, how many times it happens. So this would be frequency, total or frequency. Okay, the next column is what's called the relative frequency. So I'll make a column here and put relative frequency. So I'm going to just divide, like to make a fraction out of this. So I'm going to do 180, 180 divided by 707. So basically 25%. So I'm going to do 25.5. But really I should represent that as a decimal, not percent. So it's going to be 0.255. All right. The next one would be 195 divided by 707. 276. 64. 91. Oh, that's 91%. Should never make videos at the end of the day. This was a 6. Okay, so I got 255, 276, and 091, and 248 divided by 707. 351, and then 20, 28. Okay, so that's the column for relative frequency. Then you can do something like make a pie chart out of it. So to make a pie chart out of it, you would take this percentage and multiply it by 360 degrees. So this would be the angle that would be associated with it. So if you multiply each one of these numbers by 360, that would be how it would be proportioned out. So if we do 0.255 times 360, we get 91.8 degrees. That's probably this one right here because it looks really close to 90. So this would be the respect one. So this would be the respect circle. Okay, 0.276 times 360, 9936. 9936. That would be this one here, which is listening or communication. Okay, so that's that part, and then you could shade these in. Then the next one's only 10%, or basically 9%, so 0.091 times 360. 32 degrees. 32.76 degrees. That would be this one here, safety. The next one would be 35%, 35, 1 times 3 times 7, no, times 360, 126.36. And this would be solve problems. And then the last one's only 2%, 0.028 times 360, 10%, 10 degrees. So then this one is miscellaneous. And then you could color those in. That's how pie charts are made, like on the computer, is you have to take the number, right, of each category. That's how they're distributed. The number of each category is the distribution of the numbers divided by the total. And you get a decimal, which is like that's saying like a percent, right? That's like 25%, but 0.255. And you multiply by 360 and get an angle, and then that's how much is each part. And you can color it and all that good stuff. All right? So that's one way to represent data. This kind of data is called qualitative. Qualitative data is the quality of it, like the color of hair, or it's some attribute, like you're being respectful. Okay. Down here, we're doing GPAs. This is quantitative data. So quantitative data is a quantity, a number. So here's the distribution. I just made this one up to make it simple so you can figure out the relative frequencies faster than dividing everything on the calculator. So you can divide things on the calculator, right? But here we don't have to, because look what I did. 17 and 13 makes 40. Or no, 17 and 13 makes 30, and then this plus this makes 70. So the total is 100. So I made up the distribution of grade point averages for 100 students. So then the relative frequency is easy, right? 17 divided by 100 is 0.17, 0.25, 0.45, 0.13, right? So 13 out of 100 is 13%, which is 0.13. All right? So this is quantitative data. There's the relative frequency, and we can do things like find the average, because we have real numbers. So we'll do this a couple of different times. What you need to do here is you need to go in the middle of these. So we don't know what all the things are, but we do know that that the middle of this will be 3.5. So we're going to use 3.5 for the GPA because it's in the middle. So some people are above, some people are below. There's 17 of those. Plus an average, right? You add everything up and divide. So between these two would be 2.5, and there's 25 of those. Between these two is 1.5, and there's 45 of those. Between these two would be 0.5, and there are 13 of those. And so there's 17, 25, 45, and 13. We add all those people together, so there's 100 GPAs that we're figuring out. So this would be the average between these. So we have 3.5 times 17 plus 2.5 times by 25 plus 1.5 times by 45 plus 0.5 times by 13 is equal to that. So there's that much grade point average. And then we're going to divide by 100 is equal to 1.96. So the average of this, the GPA average, is 1.96. Ta-da! All right, so we added them all up. So instead of typing in 3.5, 17 times, I just said 3.5 times 17. So So that's how you find that. All right. So frequency distribution are how the numbers are split up over different categories or different sets of numbers. So here the numbers are split up over different categories, like words. So words go with qualitative data, right? And numbers, the numbers are split up over numbers, right? So we can actually have a measurement of that, and that's quantitative data. Okay. There's different, like I said, there's different ways to represent the data. So here we represented it with a pie chart. Here we can take data and we can represent it what's called a stem and leaf plot. So we're going to use the first two digits of the stem, or first two digits as the stem. So what we do is we survey over the numbers, and we see 150s, we see 140s. Do we see any 130s? I don't think so. So there's 140s, there's 150s, there's 160s, 160s, and is there a 170? I don't think so. So we go through and we look for the smallest number, and we put like a dash here. Okay. So I don't have to write them all out in order. I can make it shorter. So 141 looks like the smallest number. So if I put a 1 right there, that means 141. Then this looks like the next biggest number, 2. So if I put a 2 here, right, so I have 141 and 142. So I can take a lot of number and put it in a small space. Other 140s, 144, so I can put a 4 here, and I can put a 9 now. I think that's all the 140s. So in a smaller space, I have 141, 142, 144, 149. And if I do it this way, I also have the numbers in order. Now I move on to the 150s. There, oh, 149 a second time. No, it's not a second time. I just forgot to mark it off. Okay, 150, so I put a 0. 51. 53 twice. There are 52. This is the hardest part, is putting in this in order. 55. 59. 63. Oh, okay, now I'm to the 60s. 63. 66. Another 66. And 69. Okay, so I marked everything out. Oh crap, there's a 67 there, missed it. Okay, so white this out. I only made one mistake. Yay, 67, 69. Now it's worth going through and counting this. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 pieces of information. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it appears to have a matchy-matchy thing going on here. It matches. So there's two advantages of the stem and leaf. One, all of these numbers are now condensed into a smaller space. So if you can like look at it. 2, they're all in order. 3, there's a third advantage, isn't there? There's 3 is I know how many 150s I have. I can see the 150s dominate. 160s are next, and the 140s are the lowest. So you can kind of visually, it even, you know, you turn it like this, and it kind of looks like a bar graph kind of situation. You can see, oh, there's more of these. Okay, so that's a stem and leaf plot. So you have your stems, your main parts, and your leaves. So the first two digits, are the stems, and then these things coming off here are the leaves. And you may have made a stem and leaf plot before. All right, so here's the assignment in section 8.1. Ta-da!